In this video, we will answer a variety of questions about sine and cosine graphs. Number 5, true or false, the graph of y equals sine 2x has half the period of y equals sine 4x. Justify your answer mathematically. Show work here. Well, let's start with y equals sine of 2x. And let's figure out what the period is. Well, in this case, the period is always 2 pi divided by the b value. So the b value is 2, so that would be 2 pi over 2. So that period would be pi. So let's start with that. Let's call that the blue period. Now, let's do the other one in pink so we can keep them straight. So now let's look at y equals sine 4x. Now the period again would be 2 pi divided by the b value. So that would be 2 pi divided by 4. Now 2 goes into 4 twice. So this is going to be pi over 2. 2 pi divided by 4. So if you weren't sure about that for some strange reason, 2 pi over 4, oh look, pi over 2. So you can cheat and use your calculator if you must. So the question is the first one half the period of the second one? Well, that is false, because the first one is pi and the second one is half of pi. So the first one is actually double the period of the second one, not half. So that is false. Alright, let's take a look at number 6. A trigonometric graph has an amplitude of 4 and a minimum value of 5. What is the maximum value? Well, let's make a little sketch of a trig function like this. So we need something that has an amplitude of 4 and a minimum value of 5. So picture, let's say, so here's the midline. All right, this is not necessarily the x-axis, it's just some sort of a midline. And meanwhile, the trigonometric function is doing like this. It's going up and down, above and below this midline. Okay, now if the amplitude is 4, then doesn't that mean that this is going to be going up 4, okay, and down 4? Okay, so just keep that in mind. Now, meanwhile, it has a minimum value of 5. So that means, if I put this on some sort of a y-axis here, all right, so here's my y-axis. Now, this is not necessarily the x-axis, okay? This is just some midline. But what I can tell you is right here is my minimum value of 5. That's my minimum value. Now, my maximum value is going to be up here somewhere, okay? But looking at the amplitude, it's going 4 down and it's going 4 up. So, this is going to be, if I went 4 higher than 5, then this must be 9 up here. That must be 9. If I can drop down 4 lower and get down to 5, this must be 9. And if I go 4 up higher than 9, this must be 13. So the midline must be 9. So if I'm going up 4, I get to 13. I'm going down 4, I get to my minimum value of 5. So my maximum value is 13. That means the answer is D. All right, it's a little bit tricky. Or you could have looked at it this way. The total here is 8 because of the 2 4s of the amplitude. So I could have said, okay, if my minimum value is 5, just add 8 to that, and that should give me my maximum value. All right, at any rate, number 7, which is an equation of the cosine function with an amplitude 2. Okay, they all have amplitude 2, so that's not helping me. Period of pi, let's deal with that. Okay, the period is supposed to be pi. So let's see. Looking at the first one, all right, this period would be 2 pi divided by 1/2. Okay, because that's my b value, would be 1/2. Do you see it? But that would be 2 pi times 2. That would be 4 pi. So A has a period of 4 pi, not pi. So A is not the answer. Okay, this has the same b value, so that's not the answer either. So that leaves me with these two guys. Both of them have the same b value. So in both cases, the period would be 2 pi divided by the b value. So 2 pi divided by 2 does give me a period of pi. So far, C and D are both working. All right, C and D both have an amplitude of 2, and they both have a period of pi. All that's left is the phase shift, which is supposed to be pi over 2. So the phase shift comes from this part that's like 2x minus pi. But it happens once I pull the 2 outside of parentheses. If I do that, I'm going to wind up dividing both of these by the 2 to figure out what goes on the inside. So these 2's cancel, that gives me x, and here I'd have minus pi over 2. Alright, and so that gives me a phase shift of positive pi over 2, because it's going to be the opposite of that. Okay, so that means C is going to be the answer. Okay, so the answer is C. Just for fun, let's look at what the phase shift of D would have been, and you'll see that it wasn't going to be pi over 2. Alright, the main thing is you can't look at this and go, oh look, there's the phase shift right there. No way. What you have to do is you look at this part. Okay, you see that we have 2x minus pi over 2. But to get the phase shift out of it, you need to pull the 2 outside of parentheses. And if you do that, in order to figure out what goes on the inside, you need to divide by the factor that you're pulling out. So those will cancel. That leaves me x. Why did I put an equal sign? I don't know. I should not have. So it's a matter of what's pi over 2 divided by 2. Well, if you've had experience, you know that these are going to wind up multiplying, and that's going to give me pi over 4. So this phase shift would be pi over 4, not pi over 2. If you need a calculator for this, pi over 2 divided by 2, do you know what I mean? You don't have to be like me all the time. You don't have to be on my level with my awesome skills. Alright, you can be lame and use a calculator if you need to. Alright, so the answer is C. Alright, I'm taunting you because I do want you to learn how to do these things without a calculator. Okay, I hope you didn't find that too hurtful. Number 8. Which of the following values of x would not be an x-intercept of the function y equals sine x? Which would not be an x-intercept? Well, we long ago looked at this parent function y equals sine x. Let's look back through the history. Oh look, it's right here. So when we first learned about the sine function, we understood that it had a period of 2 pi. Okay, just look at the yellow part. This is one period of 2 pi. And it came from the unit circle in the way that one trip around the unit circle was 2 pi. Anyway, we found that it started here at 0 and it went up and went down. And if this was 2 pi, then this is how it broke down. Pi, pi over 2, 3 pi over 2. And we could continue the pattern like this. So anyway, what was the question again? Which would not be an x-intercept? Let's see. So they're talking about x-intercepts. Look at these x-intercepts. 0, pi, 2 pi, 3 pi, 4 pi. And in the negative direction, negative pi, negative 2 pi. So any multiple of pi is going to be an x-intercept. All right, 1 pi, 2 pi, 3 pi, negative 1 pi, 2 pi, 3 pi. So that means this would be an x-intercept, this would be an x-intercept. Okay, even this would be an x-intercept because it looked tricky. For a minute it looked like this would not be, but it reduces, doesn't it? 4 is divisible by 2. So this is really a stealth 2 pi. So all of these are multiples of pi. So all of these are x-intercepts. The only one that's not an x-intercept is D. D is the only one that is not an x-intercept. And you can see it right here. What, 3 pi over 2? Yeah, see, 3 pi over 2, it's, the value of sine is negative 1. All right, it's not on the x-axis there. Brilliant. All right, what else you got? All right, one more. Let's do one more question on this video of miscellaneous questions about sine and cosine. Number 9. Name 2 values for theta that would result in cosine theta being 0. We're talking radians. Again, we could just sketch out the cosine function as we've done many times before. We know the cosine function has a period of 2 pi, and we already talked about this. You've got pi, pi over 2, 3 pi over 2, and we know that the cosine function starts off high, all right, at 1, and it goes to a low of negative 1. And we could continue that pattern for as much paper as we had in both directions. But this pink here is showing you the period that we usually begin with. Anyway, what was the question? Sometimes I talk so much that I forget the question. Name 2 values for theta that would result in cosine theta being 0. All right, so it's kind of the same thing. X-intercepts. If the cosine is 0, then we're talking x-intercepts again. So within the normal, well, the initial period that we usually start with, we have 2 of them. We have pi over 2 and 3 pi over 2. So they just said name 2 values. So I think we've done it. So we have pi over 2 and we have 3 pi over 2. Okay, obviously we could have gone on from there and we could have done like 5 pi over 2 and 7 pi over 2. Okay, or we could have gone negatives. I could have said negative 5 pi over 2, negative 3 pi over 2. All right, but we went ahead with the obvious choices. There's another way to think about this. If we look at the unit circle, then when we talk about cosine being 0, that's going to happen at certain quadrantal angles. What am I talking about? Well, remember that cosine is the x value on a unit circle. Now, think about these key values that are here, 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 and here. What are the coordinates of these points? This is the point 1, 0. this is 0, comma 1. This is negative 1, comma 0, and this is 0, comma negative 1. All right, the cosine at each one of these angles is going to be the x value. So the cosine here is going to be 1 and 0 and negative 1 and 0. But we wanted to know at which angles will the cosine be 0. So I can just unhighlight this one and this one because these are the two angles where cosine is 0. Now, what are these angles? Well, looking from standard position, if this is standard position, then this is going to be pi over 2. Okay, which is right there. If I kept going around to this angle, then this is going to be 3 pi over 2. Remember, 1 pi over 2, 2 pi over 2, 3 pi over 2. So these are the two angles looking at the unit circle, pi over 2 and 3 pi over 2, where the cosine is 0. All right, either way you get the same answer. Okay. All right, so that was number 9, and that's going to be a good place to end this video. In the next video, we will write some equations for some given information. So if you're interested in that, I will see you on the next video.